next page. Now, this should be pretty easy because we just took numbers in standard form and put them in scientific notation. Now you're going to do the opposite. You're going to take numbers in scientific notation and put them in standard form. Before we do that, you need to understand something about the powers of 10. Anything to the 0 power, 10 to the 0 power is always equal to 1. Okay, so in standard form is 1. That's a really special rule. Anything to the 0 power is 1. Now 10 to the first power is just 10. Okay, in standard form, that's 10. 10 to the second power means 10 times 10. Well, 10 times 10 is 100. 10 to the third power, 10 times 10 times 10, which is 1,000. 10 to the fourth power, you can kind of figure out the pattern here. 10 times 10 times 10 times 10, which is 10,000. And 10 to the fifth power, 10 times 10 times 10 times 10 times 10 is 100,000. Okay, now with the negative exponents, 10 to the negative first power is actually 0.1 because it's really 1 over 10. Okay, 10, and then that would be right here, 0.1. 10 to the negative second power is 1/10 times 1/10, which is 1/100th, which is 0.01. I'll just write that again over here. Hopefully you kind of see a pattern that's going on. So 10 to the negative third power is 1/10 times 1/10 times 1/10, which is 1/1000th. 0.001 is how you write 1/1000th. 10 to the negative fourth is 1/10 times 1/10 times 1/10 multiplied by 1/10. So you have 1 over 10,000. 1/10,000th looks like 0.001. Oops, 0001. And 10 to the negative fifth is 1/10 times 1/10 times 1/10 times 1/10 times 1/10. And that is 1 over 100,000. So 1/100,000th is 0.00001. So if you kind of take a look at how this exponent is affecting the decimal, we can see, let me get the next page here. When you look at the exponent in standard form column, how does the exponent affect the standard form? The exponent moves the decimal over the same amount of place value spots as the decimal says. So I'll kind of show you that here. Back on your chart. So 10 to the first, we were at 1. 10 to the first, hit the decimal to the end. 10 to the second went 1, 2. 10 to the third went 1, 2, 3. 10 to the fourth, 1, 2, 3, 4. And 10 to the fifth, 1, 2, 3, 4, 5. Because the base that you always start at is 1. 10 to the 0 is 1. Okay, so if I have 10 to the 0 being 1, now 10 to the negative first, it was here, so it went 0.1. 0.1, I'll go over here. And then it was 1, so 10 to the negative second went 1, 2. 10 to the negative third went 1, 2, 3. 10 to the negative fourth, 1, 2, 3, 4. 10 to the negative fifth, 1, 2, 3, 4, 5. So that's kind of how you can see that exponent relates to moving the decimal. Okay, and to review this again, scientific notation is just a method to write very large, okay, very small, like this number, numbers in shortened form. So let's do a little bit of practice here. So you're going to take these numbers and you are going to write them in standard form. Now, 1.53463 times 10 to the 5th, the 5 tells you to move the decimal point, and we're going to move it to the right because we are making a larger number. So I take my decimal, I move it 5 place values, 1, 2, 3, 4, 5. It's now at the end. So I have 1, 5, 3, 4, 6, 3. To put my comma in there, I go from the back in every third number. So 153,463. Next one, 3.435953 times 10 to the third. The 3 says make this a bigger number, move it to the right. 1, 2, 3 goes right there. So 3435.953. Okay, I don't use the 953 to count for my comma. I go from the decimal in every third number, put a comma. 2.42 times 10 to the 4th. Move the decimal 4 spots to the right. So 1, 2. Oh, I ran out of numbers. 3, 4. Have to fill it in with zeros. 2, 4, 2, 0, 0. Put my comma in every third number from the back. 24,200. Okay, 5.35 times 10 to the negative third. 3 spots to the left because we're making a smaller number. So I'm going to start with 535. And I know my decimal was here, so I go 1, 2, 3. It's now right here. I have 0.00535, and I could throw a 0 out front if I want to, but you don't have to. 6.73 times 10 to the negative second. Move the decimal 2 spots to the left to make a smaller number. So 673, 2 spots to the left. 1, 2. So now I have 0.0673. And last one for the front. 2.98342 times 10 to the negative 5th. So that's 5 spots to the left. We're making a smaller number. So this is actually going to be a lot longer than the regular form. It's not shortened that much. 2.98342. Okay, 5 spots. So 1, 2, 3, 4, 5. 1, 2, 3, 4 zeros out front because I count my first number as my 5th. So 0.000298342. So this is a really long form, and that is somewhat shorter. Okay, on the back side. Sometimes you've seen a funky looking E on your calculator, and so do our calculators know scientific notation? They absolutely do. If you see an E on their calculator, E is the language on the calculator that means times 10. So our calculator can't type or display scientific notation, but it can put an E, which stands for the same thing. So it says write each number from the calculator display in standard form. Now there's the E, that means times 10. And this 10 right here is actually the power. So this one is 4.3, and then the E is times 10 to the 10th power. Now in standard form, I need to then move that decimal over 10 place values. So I have 4, 3. Okay, there's 1 spot, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put my commas in there. Every third number from the back. Next one, 1.2, E is times 10 to the negative third power. Okay, 3 spots to the left to make a smaller number. So I have 1.2, so there's 1, 2, 3 spots. So I have 0.0012. Okay, a couple on your own ones here. Why don't you go ahead and try this, push pause, and when you're ready, just push play again and you can see if you got the right answer. Okay, go ahead and check your answers for number 1 and number 2. And when you are finished with this note sheet, bring it and show it to the guest teacher, and then you can get your homework.